triangle. And again, there's nothing special about the triangle. You could do this with any triangle, okay? I just happen to pick this one right here. What I'm going to do is I'm going to write the angle bisector. I'm going to draw the angle bisector of all three sides, or all three angles. So let's start with this angle right here. So we're going to start right here. And where am I going to put this? Do I necessarily go to the middle? Is that what I do? No, what am I looking for? I'm looking to do what to this big angle right here? I'm looking to bisect it. So I don't really care where it lands right here. That's not what I'm looking for, okay? Everybody with me on this? Because we will do one in another lesson that we do care where it lands. On this one, we don't care. I'm only looking for this angle right here and trying to find out where it's going to split it in the middle. So, again, we're just going to have to eyeball this a little bit. Where do you think? Maybe go up a little bit more? Is that about it right there? Okay. All right, that's close enough. That angle and that angle, they look pretty close to each other. They might be off a little bit. That's okay. We'll fudge it at the end, okay? But but what we're trying to do now, if you had a protractor and you wanted to make sure it was perfect, feel free to do that, okay? And it'll work out real nice and pretty. Now let's do the same thing here. So again, see this big angle right here from here to here? I'm trying to split it in the middle. Where do you think it would be if I split it in the middle? About right there? Good. Now on this one, now guess what? Remember on that circumcenter? When we did that perpendicular bisector, guess what? They all three met at the same point. What do we call those 3 points if they all meet at one point? We had a name for that yesterday. No, not the point itself. Not the just in general, any 3 lines that intersect at one point. We call it concurrent lines. That's right. Okay. So they're going to be concurrent lines. These are going to be concurrent lines too, but it's not going to be the circumcenter. It's going to be something else. So that's way off. Let's start that one again. Now again, this may not look perfect because again, we're just eyeballing. But if you had a protractor, now if I bisected it, if I did it right, if I measured these things out right, guess where they're going to hit? They're going to hit right there. Now that one looks a little skinnier than that angle right there. But again, you understand, we're just kind of eyeballing a little bit, aren't we? So look what they do. If I make my dot big enough, all right, they hit each other right there, and that means all 3 lines are concurrent lines. Now this point is not called the circumcenter. It's only called the circumcenter if I did what to the sides of the triangle? Found the no. Did it yesterday. No, not midpoint. What did I do yesterday to the sides of the triangle? I didn't find the midpoint. Oh, actually, I'm sorry. You're absolutely right, Abby. I did find the midpoint, but I did more than just find the midpoint, though. I found the what? The perpendicular what? Bisector of the sides. So she's absolutely right. We did find the midpoint, okay, but then we found the perpendicular line from that midpoint. Agreed? And they all met each other. All 3 of those lines met each other. Well, same thing here. All 3 of these lines meet each other when I did what? When I found the bisector. If you want to, we could do this just to kind of show that those angles are equal to each other. Okay? So here's our situation. I split this angle in 2, I split this angle in 2, I split this angle in 2. If I did that, they're all going to meet at a common point, and this point right here is not called the circumcenter. This is called the incenter. Incenter. Okay? That's the incenter, not the circumcenter. We find the circumcenter when we do the perpendicular bisectors of the sides. Keep a list. Circumcenter, how do you get the circumcenter? The perpendicular bisector of the sides of the triangle. How do you find the incenter? I'm going to put this in quotes, or in parentheses. How did you find the incenter? What did you do to all 3 of these angles? You found the angle bisector. Alright, so to find the incenter, we take the angle bisector of all 3 of these angles. We bisect all 3 angles, and they will all meet right there at a common point. Right? And we call that point the incenter. Now, there's something special about that incenter. Now, yesterday we talked about the circumcenter. Remember, the circumcenter was the same distance from the 3 vertices of the triangle. This is not the same distance from the 3 vertices. If you look at this, this is quite a bit shorter than it is from there to there. So it's not the same distance from the 3 vertices. What it is, it's the same distance. It's equidistant from the sides of the triangle. So if I wanted to find from here down to that bottom side, what would I do? Is that the distance from there to there? From that point to that side? It is? Come on, think about it. We did this already today. Right, it's got to be perpendicular, doesn't it? Okay, so from there to there is not perpendicular. We got to take the distance from this point perpendicular to this side right here. It's not here, it's not here, it's not even there. Where is it? It's straight up and down or perpendicular. Okay, so that distance right there is going to equal. Now let's go to the other side. Now that one, that actually looks perpendicular already, doesn't it? So we can. It doesn't have to go along one of these lines. You have to understand that. Okay, it just happens on this triangle that one right there kind of looks perpendicular. I'll tell you what, we'll just move it just a little bit, just so it's not the same line, but it could be. All right, and then that's perpendicular. And let's do the same thing on the other side. Now that doesn't look perpendicular. We have to slide that over about right in here. See what I'm doing? I'm going from that point, and I'm going perpendicular to each of the sides of the triangle. Now again, it might not be perfect right now, but if I measured everything out with a protractor and all that kind of stuff, it would be right on. Okay, I'm just eyeballing, so you got to understand that a little bit. What do you think might be true about all three of these blue lines right here? They're the same length, exactly right. They are perpendicular, okay, but they're also the same length. So this blue line right here is equal to this one, which is equal to this one. So what are we saying? We're saying if you find the incenter, and how do you find the incenter? You take the angle bisector of all three angles, right? So you bisect all three angles. Bisect this, right? Split this in two, split this in two, split this in two. Guess what? They all meet at one common point. That point right there is the same distance from all three sides of the triangle. Does that make sense? Do you understand why we went perpendicular on this? Because the definition of the distance from a point to a line is the perpendicular distance. Remember way back we learned that? And you probably heard that and you're probably thinking, oh, I'll probably never use that again. But we've used it quite a bit. That's very important, that the distance from a point to a line is the perpendicular distance. Remember doing that? Okay. And there you go. So that's the incenter. That point right there is the same distance to here, and to here. All right? And that can be very, very helpful because you know what they're going to do, right? They're going to throw a bunch of numbers in there, and they're going to say, find this missing one, and all that kind of stuff. And that's what you got to know. All right? That's pretty much it for section 5.1. There might be an example or two we just didn't hit. What I would suggest to you, look, you're big kids. Your honors geometry. I know you hate hearing that and that being thrown in front of your face all the time, but it's true. You are honors geometry. I expect you to do a little bit more than what maybe a CP class would do. So I expect you to go look at the examples on the page. There's good examples on page 325. So page 325, look at the examples. It's the same stuff that we just covered, but they put it in example form, right? They put actual numbers in there and actually ask you to solve for X and Y and all that good stuff. All right, so look at the example and make sure that you look over those before you actually start doing these problems. All right, hit the white pointer, please. All right, let me give you some problems to work on here, and then tomorrow we'll just go over all of section 5.1. I tell you what, Ricky, you asked me if you could put it all in one lesson. Sure, put it all in one. I'll give you 10 points for it instead of 5. All right. So, I mean, you don't have to, like, if you're halfway done your paper on that lesson, if you just want to continue it, then that's fine. Does that make sense to you? So, what we're doing is page 328, and you're going to go 21 to 30. So basically, this whole assignment is basically 9 to 30. All right, so if you want to think of it that way. So basically, you're doing 9 to 30 on pages 327 and 328. All right. Again, make sure you look over the examples before you just start looking at the problems. Look at the examples, see what they do, and then you can go and start the problems. All right, that's it.